This is the 4.4 to 4.7 review. Number 4, calculators are not allowed, part C. This one we have the volume of a cylindrical can with the top and bottom is to be 16 pi cubic inches. The question is, if a minimum amount of tin is to be used to construct the can, what must be the height in inches? So we're going to draw the cylinder. And we see that the two things involved are the volume and the minimum amount of tin, so that's the surface area. So I'm going to write down first that we know the volume is 16 pi, and volume is a pi r squared h. We're also going to write the surface area. It has a top and a bottom, so that means we have the top and the bottom's area, which are both pi r squared, and we've got two of them, plus the area that goes around. That will be a rectangle with a circumference as its width and the height of the cylinder as its length. So that would be a 2 pi r h. Now in this particular problem, we were not told what our x is going to be. And remember, our goal is to get s in terms of x. So we are going to choose either to let h be x or to let r be x. And I personally would rather only have to replace the h, so I'm going to let my radius be x, and I'll let the height be h. So that means we will get two equations involving x and h this time. We'll have 16 pi equals a pi x squared h, and we will have the surface area equals a 2 pi x squared plus a 2 pi xh. So if I want to get this surface area in terms of x only, then that means I need to replace the h. So how I'm going to replace the h is I'm going to solve for h in this top equation. So if I do that, I will have a 16 pi divided by a pi x squared. The pi's will cancel and we'll have a 16 over an x squared. Now if we think about the minimum value of x, we know that it can shrink down to nothing. So that means 0 would be less than x. And then to get the upper limit, we'd need to set the other dimension equal to 0, which is h. And the only way h can equal 0 is if x gets really, 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 really big. So it's actually unbounded, and our domain will be 0 to infinity. So now we want to simplify this before we take the derivative, since we do not have a calculator available. So I have a 2 pi x squared plus a 32 pi times an x to the negative 1. So now I'm ready to take the derivative. That will give me a 4 pi x plus a negative 32 pi x to the negative 2. That's a 4 pi x minus a 32 pi over an x squared. Now our goal is to get this derivative to be equal to 0 or undefined, and the easiest way to do that is to set up a single fraction. So I'm going to get a common denominator here. Multiply this by an x squared over an x squared. And now, in order to get them equal to 0 or undefined, I will set the bottom equal to 0, or I'll set the top equal to 0. Well, this one gives me x equals 0, which is not in the domain, so I can't use it. But this one, I can pull out a 4 pi. That gives me an x cubed minus an 8, which will then factor into an x minus 2 and an x squared plus a 2x plus a 4. So that will equal 0 when x equals 2. So because we don't have a calculator, we need to verify that that is the location of a minimum. So we will double check that on our domain, that 2, when I plug 2 into my derivative, the bottom will be positive. The top, if I plug something smaller, say 1, I'd get a 4 pi minus a 32. That's a negative value. And after that, say 3, I'd have 27 times 4. That's significantly larger than 32. So we see that indeed S has a minimum at 2, and that, recall, was the value for the radius. So now that we know the minimum occurs when the radius is 2, that means the height will be 16 divided by 2 squared, which is 4.